Hey everybody, in this video we're going to talk about quadratic equations. And more specifically we're going to talk about what quadratic equations tell you about your graphs if you're trying to graph your equation. And the main thing to think about is that we have three ways that we write quadratic equations. So you're going to get different bits of information from each type of equation. Alright, so our three ways. The first one is the standard form. And this is probably the one that you're most familiar with, that you see the most frequently. And that is y equals ax squared plus bx plus c. The second version, or the second way to write quadratic equations, is the factored form. And you're probably familiar with this one as well. The factored form is y equals a times x minus p times x minus q. So that's what if we have the quadratic already factored. And the third one is more common in upper mathematics, but if you're first learning quadratics, you may not be familiar with this one. But it's called the vertex form. And the vertex form is when you say y equals a times x minus h squared plus k. All right, so each of these things has a unique bit of information that will tell you about the quadratic, the graph of the quadratic. You don't need to have all three in place to find these things, but as you get more comfortable with how quadratics and the graphs of them work, you'll be able to quickly identify different aspects based on however your quadratic equation is phrased. So let's start with the first one. Y equals ax squared plus bx plus c. Starting with standard form. So the first thing that we can use from this is this a here in the beginning. If this thing is positive or negative, it's going to tell us about which way the graph opens. If it's positive, it's going to open upwards, and if it's negative, it's going to open down. The second piece of information is the y-intercept. So the y-intercept is when x equals 0. So if x equals 0, everything is going to cancel out except for the c. So our y-intercept is 0, and then whatever we have as our constant in the place of c in this equation. Third thing, our axis of symmetry. The axis of symmetry is that imaginary line where the parabola could fold over on itself and completely line up. And that axis of symmetry is negative b over 2a. If you're familiar with the quadratic formula, you might recognize this as part of that formula. But this is, again, an imaginary line that helps you find where this thing is, the kind of the symmetry point or symmetry line of the parabola. And anytime you have the axis of symmetry, you can also find the vertex. The vertex is simply plugging the axis of symmetry, the x value, back into the equation of your standard form and calculating what the y value is. So we write it as f of negative b over 2a. So the x value of the vertex is the axis of symmetry, x negative b over 2a. The y value is when you plug that back into your equation. And the last thing, I hesitate almost putting this on here, but the last thing is the x-intercepts. And you can find that by using the quadratic formula. And that will tell you where it crosses the x-axis. Now, the reason I hesitate is because you kind of have to do a lot of legwork to get that information. So, and what I'm really trying to get across is what can you find quickly from your equation. So that one, you may or may not use. But these first four, the value of a, whether that's positive or negative, the y value or the y-intercept, the axis of symmetry, and the vertex, those things will all help you. So let's start by looking at an example. 2x squared minus 8x plus 1. So the first thing, the a is telling us that it's positive, so this is going to open up. It's going to open upwards. Now, it also will tell us, if it's stretching, getting wider or thinner, but you'll find that out as you start plotting some of these other points. So I don't really focus on that a whole lot to begin with. I just look on whether it opens up or down. The second thing, the y-intercept, when x equals 0, our 2x and our negative 8 cancel out, so we're left with 0, 1 for our y-intercept. The axis of symmetry, well, we're just going to take negative b over 2a. Here b is negative 8, a is 2, so we're going to have negative 8 over 2 times 2. So we just simplify that, 8 over 4, and we get our axis of symmetry being the line x equals 2. Now to find the vertex, we're just going to plug that back into our equation. So we know the x value is 2, and we have to find the y value. So we plug it in, we do some basic calculating, and we get -7. So let's graph this thing. So we've got our whole graph lined up here. So let's start plotting some of these things. We know it's going to open up. We know we've got the y-intercept at 0, 1. We know we've got an imaginary axis of symmetry at the line x equals 2. We know we have the vertex at 2, -7. So if we go to 2, -7, that is, where is that at? There it is, 2, -7. And because this thing is symmetric, these 2 points isn't quite enough. We kind of need a third point on the other side. So even though we have our axis of symmetry, if we move over 2 points, we have the y-intercept at 0, 1. So if we move 2 points in the other direction from our axis of symmetry, we get a second point. So now all we have to do is connect these things, and we've got a rough sketch of our graph. All right. So let's try our next one. So we're going to look at the factored form. So the factored form is y equals a times x minus p times x minus q. Again, we start with the a. If it's positive, it opens up. If it's negative, it opens down. The next thing we're going to find from here is our x-intercepts. This is simply when you set each of the sets of parentheses equal to 0. So if you were to solve that like you normally do, you would find that the x-intercepts are going to be where you've got p0 and q0. So you're not really worrying about that negative sign, because if we were to solve x for that, it would come out to be a positive p and a positive q. So we have to keep that in mind. Okay. So our next piece is the axis of symmetry. Again, we can find this. It's that line that's completely symmetric. Now here we don't have the A and the B to plug in, but we do have our P and Q. And if everything is symmetric, then there should be a line directly in the middle of P and Q. So what we can do is we can take the average of that. So we take P plus Q and divide it by 2, and that will give us that axis of symmetry. And like I said before, anytime you have the axis of symmetry, you can find the vertex by simply plugging the value in of P plus Q over 2, by plugging that back into the equation and solving for y. So we say f of P plus Q over 2. All right, so let's look at an example. Y equals -2 times x plus 3 times x minus 1. So this -2, that's a negative value, so that's going to tell us that it opens down. So we're going to have a downward facing parabola. Next thing is our x-intercepts. So we have to set each of these things equal to 0. So if we kind of do this in our head, here this is saying it's a positive 3. Now our natural state of the factored form is a negative, so it would be like x minus p. So since this is a negative, that means, since this is a positive, that means that value of 3 is a negative. So we've got a -3, 0. Right? So, and also you can think of, I need to set that parentheses equal to 0, so x plus 3 equals 0, and solve it. You got your you get your -3. The x minus 1, that's still in its kind of natural state, so that's our other intercept at 0, 1. Our axis of symmetry, well, we're going to take our p and our q and we're going to divide it by 2. So -3 plus 1 divided by 2, no, so that's going to be -1, right? -2 over 2, so we get -1. Our vertex, we're going to plug -1 back into the formula, or into the equation, so we get -2 times -1 plus 3 times -1 minus 1, and that gives us -2 times 2 times -2, so we get a positive 8. So our vertex is going to be -1, 8. All right, so let's graph this thing. So we've got our two x-intercepts, we have our vertex, and we have our axis of symmetry. So once we throw a graph up here, knowing that this thing is going to open down and our highest point is going to be -1, 8, we can start dropping this stuff in. Okay, so that's why I did a tall on the positive y side. So let's start with our x-intercepts. We've got those dropped in, -3 and 0, 1 and 0. we put our line of symmetry in here, throw up our vertex, and now we can do a quick sketch of this graph. So again, it's all just about how we can find a quick way to sketch this out. If you wanted to find the Y-intercept to make sure that you're going exactly through that spot, you can. If you want to find the symmetric value of that Y-intercept on the other side of the axis of symmetry, you can do that as well. Like I said, this is just a quick way to get a quick sketch drawn. All right, so let's look at our last situation, the vertex form. All right, so that is, again, we've got A. That's going to tell us if it opens up or down, right? Positive or negative. Same as all three quadratic equations here. And we also have our axis of symmetry. Our axis of symmetry is going to be the line x equals h. And the reason that that's the axis of symmetry is because our vertex is written right for us. That's h and k. So kind of like the quadratic or the factored form, even though the natural state is a negative for that h, we put it down as a positive in our vertex, just like we did with the factored form. And the k at the end, that stays positive because that's what I can kind of call our natural state. So let's look at an example. Y equals negative 2 times x plus 1 squared plus 4. Okay, so we know from a negative 2 that this thing is going to open down. We know that we have our axis of symmetry at the line x equals, well again, this is a positive, and our natural state is a negative h, so a positive and a negative, so that means our axis of symmetry is going to be a negative 1. Our vertex is a negative 1, 4. Okay, so now if we can try and graph this, we don't know a whole lot about it right now, but let's see what we can come up with. So we've got our axis of symmetry, and we've got that it's opening down, and we have our vertex at negative 1, 4. Well, at this point, we don't have much to go on. So what you need to do is, because there isn't enough information here, is you might need to just pick another point. So I'm going to pick any point or a point that makes sense that might be easy to calculate to throw on my graph here. So I'm going to choose the X-intercepts. I'm sorry, the Y-intercept when x is 0. So x is 0. Now I just solve this a little bit, and we get y equals negative 2 plus 4. So we get y equals 2. So now I've got the point 0, 2, where this thing crosses the x or the y-axis. And again, because this axis of symmetry provides that symmetric boundary, we can put a point on the other side, exactly on the other side of this y-intercept, and then we can sketch a quick graph. Now, of course, you could find the x-intercepts as well. You could multiply this out. You could use the quadratic formula. You could set y equal to 0 and find out exactly where they go across. But again, I'm just trying to get a quick sketch. So all I need is really 3 points to get that for me. So hopefully this was beneficial in helping you identify some key components of the different ways that we write quadratic equations. That's not very easy to say. In the next video, we will look at how can you find the equations from various points of just looking at the graph. So hopefully this was helpful, and I'll talk to you soon.